We can now compare the required wall thickness for the B31.3 to the required wall thickness when using the EN 13480 code. We can see that the B31.3 follows the same logic as the EN 13480. Let us again zoom in on the various contributions to the thickness. In the B31.3 code, the thickness is represented by the T instead of the E. On the right-hand side, we can see that the numerator is still the same. The pressure P is multiplied with the outer diameter D. The internal design gauge pressure for the B31.3 is the same pressure as the calculation pressure in the EN 13480. It is the pressure related to the most severe operating conditions. During the design stage, the design pressure is used for the determination of the wall thickness. In the denominator, we can again recognize the allowable stress, S in this case, along with two reduction factors. The factors E and W. E is the quality factor and W is the weld joint strength reduction factor. The pressure term in the denominator is also present for the B31.3 code. In B31.3, however, it is multiplied with 2 times Y, which is an additional coefficient. Let's discuss the two reduction factors and the additional coefficient and look at them in more detail. The quality factor, E, is based on the manufacturing process and inspection level of a pipe. 3 categories are distinguished. For seamless pipes, so pipes without welds in longitudinal direction, the quality factor, E, equals 1. For longitudinally or helically welded pipes, the value should be looked up in Table A-1B in the B31.3 code. It ranges between 0.6, where no inspection of the welds is applied, to 1 with specific welds and 100% radiographed inspection. This principle is similar to the joint coefficient Z in the EN 13480 code. For cast pipes, the quality factor, E, can be looked up in Table A-1A. Like the joint coefficient, Z, the quality factor, E, reduces the allowable stress in the pipe to prevent failure at the longitudinal welds. The ASME B31.3 provides an additional safety factor, the weld joint strength reduction factor, W. The factor, W, is introduced because the long-term strength of weld joints at elevated temperatures may be lower than the strength of the base material. This factor is dependent on the manufacturing process, the temperature, and the material type. Seamless pipes have no welds. So, the weld strength reduction factor is 1. Welded pipes below temperatures of 427 degrees Celsius have a weld joint strength reduction factor of 1. Above this temperature, the value should be looked up in Table 302.3.5. The value of the weld strength reduction factor varies between 0.5 and 1. To determine the influence of the additional coefficient, Y, let's have a look at this bar that ranges from most conservative to least conservative. When implementing Y equals 0, the rewritten equation for the stress in the pipe is similar to the standard equation for the hoop stress P, D, over 2, T. This is the most conservative value for Y that can be picked. In the equation we can see that the higher the Y factor gets, the lower the stress in the pipe becomes. So, higher values for Y provide less conservative results. The highest allowable value for Y in the B31.3 design code is 0.7. When we fill in this value, the least conservative calculation is used. However, the numerator is still larger than when the inner diameter would be used in the calculation. This means that this is still a more conservative approach than using the inner diameter. For steel below 482 degrees Celsius, Y equals 0.4. This value can be filled into the equation and used to determine the minimum required wall thickness. This is slightly more conservative than the EN 13480, which is equivalent to having a Y equal to 0.5. Values for Y at higher temperatures need to be looked up in Table 304.1.1. Y varies between 0 and 0.7.